Hey guys, today is the day 11 of the 28 days data science AI Gen AI challenge. So we have seen a lot of things in neural network. We have seen what is the basics of neural network. We have seen what are the activation function. Today we are going to learn about what is training in neural network. So we have touch base that neural network consists of various components, right? We are going to look into those things again, but try to put forward an example of neural network. It can be used for image recognition. It can be used for forecasting the stock market prices, right? So many things. There are so many benefits of neural network. There's so many applications of neural network. So today I'm going to focus on the training part of it. Okay, so let's try to dive into that. So very quick understanding of neural networks. I think so I have spoken about it multiple times, but still. So neural network is nothing but it tries to mimic the human brains, right? When I talk about mimicking the human brains, it's very important to understand it has neurons, and very similar to neural network also we have neurons and all. Okay, there's something very specific thing which I'm going to talk about in the later slide. But remember that there's a very important thing called backward propagation, which happens in neural network. That is the most important thing which makes neural network much ahead of normal machine learning languages. Okay, so remember the backward propagation. Beyond that, you would have heard about all these applications, which is very important. So those applications are, of course, there are so many applications around neural network. It can be used for image recognition. It can be used for speech to text conversion, stock prediction. Stock prediction can be very difficult, but at the same time, I would say it enhances the concept of stock predictions, right? So there are a lot of algo traders which can be used. Algo traders can be built upon the neural network. Okay, and I'm going to put forward the key structure of the components, right? Remember, a neural network consists of, I'll just put forward the things what neural network consists of. Consists of an input layer, as you can see. Consists of input layer. It consists of hidden layer, right? And it consists of an output layer. So you have understood this, right? But at the same time, when we calculate our input and its given weights, so it would have inputs, and every time there would be some kind of weights. So input layer, the input feature with the weight, with the activation function, when we calculate all these things, this is the process of forward propagation. Okay, then at the end, remember there is some operation which happens at the end, right? We are going to look into those operations. Those operations are nothing but calculation of the losses. Based on that calculation of losses, we try to do one level of backward propagation, which we're going to deep dive into that, trying to understand step by step what other things is possible. If you want to take an example of it, right? Consider trading a neural network is like cooking. Okay, so forward propagation is nothing but you're mixing all the ingredients, right? And then backward propagation is more like adjusting the recipe when the taste is not right. When you, for example, at the end of the recipe you understand that there's a bit of less salt, right? So what you do, you go back and put a bit of salt. So it is technically improving the dish, right? So to make sure that the dish is perfect at the end of the day. So that is the idea of backward propagation. But no worries, let me try to explain a bit more about it. But always remember, when we are doing all these operations, even right now, data plays a very important role. Okay, because if data is not good, then it is going to have a lot of issues, right? So hence, data preparation plays a very important role. You need to clean the data, you need to handle the missing values, you need to do feature scaling. With the help, you can use multiple algorithms around it. So the algorithm which I choose a lot of time is called standard scalar. You can always also use min max scalar. But remember, standard scalar or min max scalar, both kind of standardization kind of algorithm helps in your model, right? Then of course do the train test split. Never forget that, because it helps to be more confident when you're going to implement this model into the production side of it. Okay, so these are the common data preparations thing which you need to do, and when I'm going to show you the Google Colab code also, it's going to happen. Okay, so don't get confused in these concepts. Now, what is So when we think about backward propagation, right, always understand two things are going to happen in that operation, right? There would be a learning rate. So learning rate is nothing but how fast are you learning? Okay, how fast are you making sure that you are reaching to the optimal model? Okay, it cannot be very fast, because if it is very fast, it might crash. Okay, and if it's very slow, it will never reach the optimal model itself. So you need to balance your learning rate. Cost function, always remember, if it is a regression problem statement or it is a classification problem statement, both the problem statement would have some kind of matrix. For example, in a regression problem statement, I would look into the mean square error kind of stuff. In a classification kind of problem statement, I can look into accuracy, I can look into cross entropy, a lot of stuff. So need to measure what kind of cost function, what kind of metrics I'm going to measuring to understand is the loss reducing as we going to as we're doing this backward propagation again and again. Okay, so now once you understand the learning rate and cost function, you will understand what is backward propagation. So in backward propagation, as we know, as I took the example of a recipe. So once you get the result, right, what happens is a compute of loss. So basically, you know what is a loss function, right? So basically y minus y hat. So technically, based on the actual output minus the predicted output, what is the reality of loss? What is the reality of how much error do we have? So we compute the loss of that. Okay, once you compute the loss, then you calculate the gradient. So it understands that how much weight I have to go ahead and how much weight I have to update. Because remember, only weights can be updated. Input features cannot be updated. The input features are going to be like that only. The weights are going to get updated. It will understand that which weight how much loss is being calculated because of this neuron. So let's say, for example, if this neuron is very important to update, very important because of this neuron is creating a lot of error in my resultant. So what I will do is that I'll reduce the weight so that it doesn't have much importance on that. So something like that. So the updation of the weight happens, and once the updation of it happens, again I will rerun this whole thing again. Okay, so keep doing this again and again till I get a proper loss, or I will say that the lowest loss possible. Okay, when I'm doing this repeated thing again and again, right, it is nothing but the epoch thing, the loop thing, right? Now you understand about this. Okay, remember that when we are thinking about this loop, right, it's very important to understand the optimization techniques. Though the thing what I have spoken about, the first is the gradient descent. The gradient descent is nothing but, if you think about a big thing, so this is the optimal loss which is possible in a given model. So it keeps learning from in every learning rate, and the idea is to reach to the optimal loss. So this process of finding the optimal loss or finding the optimal model with the minimum loss is called gradient descent. But similarly, we have other optimizer also, Adam, RMS, prop, momentum. Adam is also a very famous optimizer, right? But explaining each and every optimizer can make a totally big video, so I'll explain that in some other video. Okay, so remember our optimizer algorithms, which I'm going to showcase you also in the code where exactly I have used the optimizer algorithm. Okay, now you will understand that this process of forward propagation, then backward propagation, then updating weight is nothing but a continuous process. Okay, so training the model or training your neural network is kind of marathon. Okay, which each iteration makes the neural network smarter and more accurate. Okay, so remember, it is not a sprint. It cannot be done one or twice or thrice. It can have multiple epochs. Okay, now before I go ahead, right, always remember that finding the right balance of epoch, finding the right balance of learning rate, finding the right balance of what should be my number of activation function, or what kind of activation function I would like to have. This all defines how good can be your neural network at the end of the day. Okay, so that is something which I like to put forward at the end. So training neural network can be complex because it has multiple steps, right? You have to clean the data, you have to put forward the right learning rate, you have to do the backward propagation magic, you have to build the powerful model, you have to do all this small stuff and all, right? But it is an experiment. Because you have to put forward different kind of parameters, you have to do it multiple times to make sure that your neural network becomes much more smarter, much more better with each iteration. Okay, but as I always told you, if you have any questions around it, please put forward those questions in the comment box. I'm happy to share about it. I know this video has become a bit longer, but this is a very interesting concept, Hans. Okay, so please go ahead and see the code what I have written. Thank you. This is the Google Colab part of day 9 training neural network, right? So as you know, I have put forward my Discord server link, GitHub link, YouTube link, LinkedIn link. There's a lot of spaces where you can come forward and ask your questions. Like every time, I have divided all the codes in different cell. I have put forward a title, what exactly is happening behind the box. Okay, so here this is a problem statement where I'm going to use a dataset called load breast cancer. The idea would be to predict whether somebody is going to get cancer or not. Okay, I've brought forward all the required libraries. Like last time, I'm going to use keras for this neural network. Okay, and then I have used the optimizer, and the optimizer is gradient descent because in the previous slide I have explained what is gradient descent. There are multiple other optimizers like Adam. It is very common and very famous. You can use that too. Okay, now the first cell brings all the important libraries. Second cell, as I've shared the last time, make sure that your dataset is very good in terms of clean the dataset, standardize the dataset, split the dataset, right? Now in this dataset I have not checked for missing data because I know this dataset doesn't have any kind of missing data because it is a very good data. It's a standard data which is brought into library. I'm using that data itself. Okay, so I've done that. I've built a neural network. It's very easy to understand the build when we are using keras because actually we are going to put forward the actual sequence of the network. The first slide explains the input layer, the hidden layer. The first hidden layer consists of 16 neurons. The second hidden layer consists of 8 neurons. The activation function which I have used is ReLU. At the end I have used sigmoid. Reason behind I have used sigmoid at the end because there's only two possibility, 0 and 1, as the sigmoid activation function does, right? Very important part is this part where I have explained in today's slide how are we going to keep two important factor, which is the learning rate and loss function. Learning rate I have kept at 0.01 with the help of gradient descent as one of my optimizer, and for my calculation of loss function I have used binary cross entropy, and the matrix which it is going to check is the accuracy. Very important. Then I have trained my model. I have used the train data set X-train and Y-train, right? And I have used epoch of 50. Reason behind I have kept 50, not 1000 like last time. Reason behind that is because you will see as I go ahead in the visualization, within 50 itself it gives me a very good predictions. So because at the end you have to explain it to your stakeholder, I put forward a visualization of the validation of the accuracy and the loss, right? If you see, my accuracy score jumps from 90% for training data set. It jumps from 80% to somewhere around 97%. Okay, as we go on, the difference is not much also. It is somewhere 95 to 97. Technically it is a good fit model. Okay, in the same sense, as we go on, the training and validation loss also reduces drastically. Okay, somewhere around 25 or something like that, the training loss and validation loss comes together at the same point. But still there is not much difference, I would say. You can still go till 50 epoch, but the reality is that if you go beyond 50 epoch, there's not much change anymore. Okay, so save your computation and choose the most optimal number of epoch. As I've told you, neural network can have multiple processors because you have to choose the right learning rate, you have to choose the right level of epoch, right number of epoch, you have to choose the best optimizer. There are multiple parameters which you have to choose. You can also have a hyperparameterization kind of concept to implement the best neural network. Okay, so this is something which I would like to share today. In the next challenge, I'm going to come up with something advanced topic of neural network. Thank you guys. If you have reached here, it means that you have finished the video. Thanks for watching and being part of the 28 Data Science Challenge. Your support, engagement, and enthusiasm make this channel even more exciting for me. If you found this valuable,